Welcome to Engage Math, Lesson 30, Problem 1. And we are solving equations where we are going to use the process of factoring and using the zero product property. I'm going to zoom in because some of these problems take a lot of work and you're going to need to be able to see what's going on. So, x squared minus 8x plus 12. To factor, we always look for a GCF first, and there is no GCF. So we look, okay, there's three terms. The leading coefficient is just a 1. So it becomes an AM problem where we're adding to negative 8 and multiplying to positive 12. So we have x minus 6 and x minus 2, the two numbers that add to negative 8 and multiply to positive 12. Now, the zero product property says that if two things multiplied together, two quantities multiplied together give you 0, x minus 6 must be 0, or x minus 2 equals 0. If either x minus 6 or x minus 2 is 0, the entire equation will be true because we will get 0 on the left, and that's going to be equal to the 0 on the right. So I'm not going to show the work of solving this, but x equals 6, x equals 2. We simply added 6 to both sides, and then we added 2 to both sides of the equal sign. So these are our two answers for number 1. If you're not sure how I'm factoring, please go back to earlier Engage Math factoring lessons to make sure you have those skills down really well. All right, the next one, there's no GCF. So we recognize that there's two terms. When there's two terms and no greatest common factor that we were able to take out, we can say, well, maybe it's the difference of two squares. And in this case it is, because we know the square root of the first term is c, the square root of the second term is 20. So we simply have to do c minus 20 and c plus 20. If you want to see that actually would multiply back out to c squared minus 400, please just do that and see that we have not changed the value. We've just changed the form of c squared minus 400. And the reason we did that is because now we have one quantity times another quantity that equals 0. So one of those two can be equal to 0 and make our equation true. So c equals 20. That's one answer. C equals negative 20 is another answer for x that would make that equation true. All right, let's move on to C. All right, so I'm going to make the left-hand side equal to 0. So I'm going to do that by subtracting 7g squared from both sides and 5g from both sides. Okay, so the reason I know the left-hand side is equal to 0 is those cancel. So now I have 0 equals, and I'm going to rewrite that 0 right here. 0 equals 10g squared minus 11g minus 6. All right, because there is no greatest common factor and that leading coefficient is not a 1, we are going to do a method that Engage Math has taught in earlier lessons called splitting the middle term. Certainly not the other way to do it, the only way to do it, but there are other ways, but this is a great way. So 10 times negative 6 is negative 60. Now we have to think of the two numbers that multiply to negative 60 and add to negative 11. Those are going to be negative 15 and 4. So now we have 0 equals 10g squared minus 15g. And it would be fine if you wanted to put the plus 4g first, but it doesn't matter. It'll come out the same in the end. Okay. So we have literally split the negative 11g into negative 15 plus 4, which is why it's called splitting the middle term. So now I'm going to group these 2 and 2. So I'll group those first two and the second two. From the first two, I'm going to take a 5g to the outside, leaving us with a 2g minus 3. And then from the last two terms, I'm also going to just take out a 2, leaving us with a 2g minus 3 again. Now we know we've done it right when these two parentheses match. So now we can take out what is now the greatest common factor of 2g minus 3. And we have 2g minus 3, and left over is this 5g plus 2. So we have factored the original problem. Now, based on our zero product property, we can now say 2g minus 3 equals 0. And I'm not going to show the work for this, but we know how to solve that equation. 2g equals 3 halves. And then we can also say 5g plus 2 equals 0. And so that would give us g equals negative 2 fifths. And these are our two answers that make the equation true. Okay, let's move on to D. So in this case, again, there's no GCF, but we're going to split the middle term again. So 3 times 4 is going to give us 12. The two numbers that multiply to 12 and add to 8 are 6 and 2. So we have 4p squared plus 6p plus 2p plus 3 equals 0. We're going to group 2 and 2, and we're going to take a 2p from the first two, which gives us 2p plus 3. And the only thing from the last two terms is a 1, but I'm going to put that on the outside as a reminder that I need that when I factor. This is still equal to 0. We have not changed the equation. We have just written it in a different form. And now I can take out the 2p plus 1 because the greatest common factor between those two terms now is the 2p plus 3. So that's equal to 0. Zero product property says if two things multiply, two or more quantities multiply together to give you 0, something has to be 0. So let's do 2p plus 1 is 0 and 2p plus 3 equals 0. This is going to give us p equals negative 1/2, and this will give us p equals negative 3/2. Okay, and those are our two values for p there. Okay, let's go to E, and in problem E, I actually think E is a little bit trickier even than F, but I think they could actually both be light bulbs. So don't get discouraged if you think E is a little tricky. So we're going to start by subtracting 11 from both sides of the equation. And then we get 3x squared plus 15x equals 0. Now, based on our factoring skills, we're going to take out a GCF, which in this case is 3x, and we're left with x plus 5, because we always want to factor here. And now we have two different equations. So the first equation is going to be that 3x equals 0. And the second equation, and I'm just going to kind of that leads us to the fact that x equals 0. That's one of our answers. And the other is that x plus 5 equals 0, which leads us to x equals negative 5. And those are our two answers for problem E. Let's look at F. So for F, you have to recognize that you have to bring the 5x to the left-hand side. So you're basically adding 5x to both sides. Not going to show that work as this is a light bulb problem, but it's 8x squared plus 5x equals 0. Our greatest common factor is just x. So we have 8x squared becomes x times the 8x, and then we need a plus 5 to get the plus 5x. All right, set each one equal to 0. So x equals 0, and then the other is going to be 8x plus 5 equals 0. So our two answers are x equals 0 and x equals negative 5/8. All right. Okay, now we have a couple more light bulbs. All right, these are really tricky. So I'm going to really zoom in for G because we're going to need a lot of space. So the idea here is this is what I would call a quadratic problem, a quadratic equation in disguise. So I'm going to rewrite it first as x squared minus 2x, the quantity squared, minus 11 times the x squared minus 2x. And I'm going to move that 24 to the left-hand side, so I'm going to make it plus 24 equals 0. Now, I'm going to have you think for 1 minute about something. If this problem was x squared minus 11x plus 24, you would be able to think right away, oh, we just have to add to negative 11 and multiply to 24. So you would really quickly tell me, oh, we can write it as x minus 8 and x minus 3. However, the x in this case is this entire parentheses, but that's no problem. I'm going to leave this down here as our hint for a minute, but I'm going to erase that in a few minutes. So what we're going to do is we're going to write our double parentheses. And what I'm going to do is I'm going to put a minus 8 and a minus 3, just like we have here, minus 8, minus 3. But instead of putting x, I'm going to put x squared minus 2x. And I'm going to do the same thing here, because we're basically factoring, but the quantity, instead of just being an x, it's the entire x squared minus 2x that has to go in those first two positions. Let's erase this now so we have plenty of space. And I'm going to go back now to say this is still equal to 0. Okay, let me know if you have any questions on that, but this is a tough one. So now the x squared minus 2x minus 8 can factor again, because now it's an AM. So we know the two numbers that multiply to -8 and add to -2 are -4 and +2. And then this next problem, we're going to add to -2 and multiply to -3. So it's going to be x minus 3 and x plus 1. That's all equal to 0. And now each one of these factors can give us a solution. So our solutions are going to be x equals 4, x equals -2, x equals +3. Let me just change that. X equals +3, and x equals -1. All right, let's go on to the last light bulb problem right here. So our first step in factoring is always a GCF, which in this case is 3x. So we have 3x times x squared plus 2x minus 3 equals 0. But we can factor that trinomial. So we have x plus 3 and x minus 1 because it's an AM equals 0. And so now we set each one of these equal to 0. So 3x equals 0, which means x equals 0. That's one of our answers. X plus 3 equals 0, which gives us x equals -3. And then the final one is x minus 1 equals 0, which gives us x equals 1. And all three of these answers would give us solutions that work in the original equation. Okay, that was a tough lesson. If you have any questions, you know you can always reach back out. Okay, we'll see you next time at Engage Math.